All right, so this is the wrap up of the series circuit. So you can go ahead and jot some notes onto this slide if you'd like. Okay, but basically here is what, where'd that cool thing go before? Whoa, I don't know what that looks like. I wonder if that looks like something. Okay, what is this? Ooh. Okay, here is what the series circuit is going to look like. Okay, so this would be a 1 battery circuit with 3 resistors all hooked in series. Okay, so important note, series means 1 path. Okay, so in this circuit, the charges are only able to go in 1 path. Okay, and remember they're going to flow conventionally from the positive to the negative terminal of the battery. Okay, there's only one place for the charges to go, right? So once the battery gives that signal, remember all those charges are already existing out in the circuit. When the battery gives the signal to go, everybody goes together. Okay, and there's only one place to go. Okay, so as such, the current is the same at all points in the series circuit, right? There's nowhere else to go. If 3 amps are going through here, 3 amps have to go through here, 3 amps through here, 3 amps through here, everywhere. Okay, even through the battery, that current has to be consistent everywhere because there is only one path. Okay, all right. The other thing is when you add more resistors into the circuit. Okay, so remember, based on Ohm's law, okay, resistance and current are inversely proportional, right? So the more resistance there is, the lower the current is, all right? So in a series circuit, hopefully what you saw was that every time you added another resistor, that reading on the ammeter went lower, right? Because every time you're adding a resistor, you're putting it into the same path. So in effect, that is making it harder to travel through the circuit, okay? So more resistors in series equals harder to travel in the circuit. Okay, that means that the resistance is higher, right? It's a harder place to travel. Therefore, the current is going to be lower, okay, based on the same push from the battery, right? So that we didn't really change. Okay, the same voltage or the same push from the battery, right? So the more resistors there are in the pathway, right, it makes it overall harder to travel there. Okay, all right. So a couple of analogies that are usually pretty useful for this, and they're not great, but they're okay. So think about traffic, right? So let me draw the circuit down here. Right? Okay, so think about if we're thinking of this like roadblocks, okay, or construction zones, or toll booths, or something like this that's going to impede the flow of traffic, okay? So as these cars are moving around, you know, the freeway or whatever, right, the more roadblocks or toll booths or construction zones there are in the path, overall, it's going to be harder to travel through that freeway. Okay, therefore, less cars are going to be able to travel. Okay, remember, it's not the speed of the charges, which, you know, it's kind of confusing. Okay, what is not, it's not like they're all, you know, fast and then they slow down, fast and then they slow down, fast and then they slow down. That is not how it works. So we're going to think of it like it's one path and it's one, you know, so-called speed, but not speed, right? Like the amount of cars that could get through. Okay, so the more hindrances there are put in the path, overall, that's going to drop the rate of cars that can go through. Okay, or like at a checkout stand, right? Like if the more, you know, like if you had to go at the grocery store and you had to like check out something here, and then you had to go and you had to check out like your produce, and then the next one you had to check out your dairy or something, right? If you had to do that multiple times all in the same pathway, it would make it very difficult, okay? So that would be a higher resistance and a lower current then, okay? All right, so that's a good analogy for series circuits as far as resistance and current, okay? All right, so let's talk about voltage now. Erase all that. Okay, so let's talk about the voltage in a series circuit. Okay, let's just do 2 because it'll be a little bit easier. Okay, so hopefully you saw these little circles here, 10 and 0. Okay, this is 10 because, right, no energy has been lost during the wire. It only drops during going across a resistor. Okay, so then you should have seen, say, 5 and 0 like this. So this might be part of your evidence, right? You might have like a screenshot like this. Okay, so in voltage, the important thing to know in a series circuit, all right, is you're going to have a certain amount of voltage that's going to be created by the battery. Okay, so I have 10 volts to work with in this circuit. All right, every time those charges pass by a resistor, remember like those little guys, those little blue guys that were dumping out their cup of energy? Okay, they're dumping out their cup of energy. They have to give some to this guy and they have to give some to this guy. All right, everybody has to get something. So that's like, you know, if mom has $10, okay, but mom has 2 kids, right? Each kid is going to need to get $5, okay? Assuming they're equal, right? Assuming she loves them equally. So we're saying these resistors are equal resistance. These children are equally difficult, okay? So they're each going to get $5, all right? What we'll see later is if those children are unequally difficult, then they might get some different amount of money, okay? But for now, all we really care about is everyone has to get something. So if you just kept the same resistance, then they're all going to get equal, okay? If they have different resistances, then no, all right? So that's just like what the voltage happens. The voltage is going to drop, okay? Some amount of voltage drop here, which was a 5-volt drop, okay? And then some amount of voltage drop here, which was a 5-volt drop to get me back to 0. Okay, so we say that the voltage shares, right? The total voltage of the battery has to be equal to the voltage of the voltage drop across each resistor. Okay, all right. Okay, so let's see. All right, so if we did like a little chart, let's see if I can figure this out. In series, if you think back to the original chart that we did above, okay, if we have current, voltage, and resistance. Okay, in a series circuit, the current is the same everywhere. Okay, so we could say the total overall current is going to be I1 plus I2 plus ... right? So I'll add up the current through each resistor. Oh, no, sorry, not plus, equals. Oops, equals. I1 equals I2 equals I3. It's the same current everywhere through each resistor. Okay, and then the current also goes down when you add resistors. Okay, so the current is the same everywhere. I1, let me just make that look nicer since I botched that up. Okay, the I total equals I1 equals I2 equals etc. Okay, all right. The voltage shares. So the total voltage from the battery is going to be V1 plus V2 plus ... right? Everybody has to get a piece of that. Okay, right? So the voltage is going to add up to the total. Okay, and then the resistance, more resistors means a higher resistance. It's harder to get through the circuit when you have more resistors in series. Harder to get through the circuit. Okay, and the resistance, actually, you're going to do the same thing like you do with the voltage. The total resistance is going to be R1 plus R2 plus R3 ... Oops, ... We'll get to this more a little bit next week, okay? So as you add resistors in series, you basically have to just add up their resistance. So like if this is like a 10 ohm resistor, a 10 ohm resistor, a 10 ohm resistor, this circuit is going to have a total of 30 ohms of resistance. Okay. All right. So these are the things that you need to highlight in your presentation. Current is the same everywhere. Each resistor has the same amount of current passing through it. When you add more resistors, the current goes down because it's a harder place to travel. Okay. For voltage, it's shared between the resistors, right? Mom has a certain amount of money to give. Each kid needs to get some. So the total voltage is going to be V1 plus V2 plus V3 plus blah, blah, blah. Okay, and then for resistors, more resistors means higher resistance. It's a harder place to travel. It's harder to get through this circuit, and all those resistors just add up to the total. All right, so that is what needs to be summarized in your poster, your presentation, whatever, your final product for next week. That's the stuff that I need to have covered in it. Okay. All right. Good luck.